Lesson 6.2, sum difference and double angle identities. So we're going to start with a recap from 6.1. So what we want to do is rewrite them to look like one of the following A, B, C, D, and pick which one matches it. So we know that secant x is not allowed to equal -1. So that's just the non-permissible value. So we'll start by writing cotangent as the reciprocal of that would be then cos x over sine x plus 1 over sine x is the same as cosecant x. And that's going to divide by the bottom, which is secant x plus 1. Secant x is 1 over cos x, and then plus 1, we're going to get common denominators by multiplying the top and bottom by cos x. So that's just going to save us some time if we do 1 is the same as cos x over cos x. So what I want to do is there's common denominators, so I know that the first fraction is just going to be cos x plus 1 over sine x. And then we're going to divide it by 1 plus cos x over cos x. So we can actually flip this to become cos x plus 1 over sine x. That stays the same, but whenever we multiply, whenever we divide, we always flip it. So it's going to be cos x at the top over 1 plus cos x at the bottom. So you'll notice that these guys can cross each other off because they're factors that are identical, and then we're left with cos x over sine x. And this is actually equal to cotangent x. So that matches letter D. So these are our new identities. So these are where we take sine of two angles and we can replace them to or expand them to look like this. So this might make it easier to get exact values. So these are identities for when we have sums, when we have three angle differences, so when we have angles subtracting, and then when we have double angles, so 2 times A or cos 2A or tan 2A. So we can replace them with those identities. So for the first one, we want to match and see which one does it look like. So as you can see, there's a plus sign between them, and they're all coses. So there's cos coming first, and then there's 2 signs coming afterwards with an addition between them. So that has to be this guy right here. So we're going to write it as cos. This is going to be angle A, and this is going to be angle B. So it's going to be cos angle A minus angle B. So that's going to be cos 88 subtract 35 degrees. And that's going to equal cos. So in your calculator, 88 subtract 35 is 53 degrees. So that would be the single trig function that could replace it. Our next one, we're looking for one that has a 2 with sine, and then our angles are the same. So that looks like this one right there. So that is the double angle identity. So we're going to write it as sine of 2 times the angle A, which is the same here. They're both the same, so that's going to be pi over 12. So we can simplify that. The 2 and the 12 can simplify to sine pi over 6. So that would be the answer for the second one. And then for C, we want to look for where we have sine and cos in our identities above, minus cos and then sine. So that looks like this guy right here where we have angle A, angle B. So we're going to have to write it as sine of A minus B. So that's going to be sine of 48 degrees minus 17 degrees in our calculator. So that's going to be sine of 31. And then here we have where we have squared of cos and sine with a subtraction between them. So that is this cos double angle. So cos of 2a. So a is equal to pi over 3. So we're going to have cos of 2a. So our a value is pi over 3. So it'll be 2 pi over 3 as our final answer. Example number 2, they're asking us to determine an identity for cos 2a that contains only the sine ratio. So we're going to write it as cos a plus a first, and then we're going to expand it using the rule above. So the cos identity shows that whenever you have cos 2a, you can write it as cos a minus sine a. And so what that looks like is it's just the same as saying cos squared a minus sine squared a. And from our Pythagorean theorem identities, we actually know that cos squared a plus sine squared a equals 1. And then we can actually move this over. So cos squared a could actually be replaced with 1 minus sine squared a. So we're going to, instead of cos squared a, we're going to write 1 minus sine squared a. So that's going to replace this right there. And minus sine squared a. Now there's 2 of these that we can simplify and write it as 1 minus 2 sine squared a. Okay, so for example number 3, it says consider the expression. It says what are the non-permissible values? So you always want to take the denominator, which is cos 2x plus 1, and you want to make it equal to 0. Well, this is a double angle that we want to replace because we can't really solve for x with that double angle in that spot. So we want to replace cos 2x with, we can replace it with cos squared x minus sine squared x in this case. So this is the same thing as saying cos 2x. Now, we don't want to have 2 different ratios in there, so I'm going to replace sine squared x with, an equivalent to that is going to be the same as saying 1 minus cos squared x. Okay, so I'm going to continue over here, cos squared x minus 1, because I'm distributing that negative to the minus 1, to the 1, and it'll be plus cos squared x, because the minus in front is going to that, so it's changing the sign. And then we still have this plus 1 equals 0. So as you can see, the 2 1s will cross each other off, leaving us with 2 cos squared x equaling 0. We can divide both sides by 2, and then we can square root the 0, which leaves us with cos x equals 0. So we want to find out where cos x is equal to 0. Well, we know that that occurs at 90 and then 270. So that occurs, if we want to write it as radians, it would be then pi over 2 plus every pi. N is an element of integers. So this would be a way of representing the non-permissible value. So this is what x is not allowed to equal. It's not allowed to equal 90 degrees, which is pi over 2 plus every value if you add 180 degrees to that or subtract 180 degrees to that. And then they want us to simplify this. So we already know that we have sine 2x over cos 2x plus 1. Well, sine 2x is the same as saying 2 sine x cos x from the previous identities, if you look above. And then we already found that cos 2x plus 1 was the same as saying just 2 cos squared x. So we can simplify this by crossing off the 2's and crossing off one set of coses at the top and bottom, which leaves us with sine x over cos x, and that's equal to tan x. So there's our primary trig ratio that we can get out of it. Now we can verify our answer by going y1 is sine 2x over cos 2x plus 1, and y2 is tan x. What you should be looking for is that they overlap each other. So graphs overlap each other. And you would graph it over the domain of 0 to 2 pi. Our next one is we can use our sum angles to figure out what 165 is. So we want to replace 165 with angles that we can find exact values for. So for example, cos 165, we can actually write it as 120 degrees plus 45 degrees, because 120 plus 45 is still equal to 165. And then we can use our identities above to write it as cos A times cos B, subtract sine A times sine B. Now we know that when we have our triangles, 45 degrees, if we have a 45 degree special triangle angle, we have the angles of 1, 1, root 2. If we have the value of 30 degrees, that's equal to pi over 6, and that's opposite to 1. And then we have the value of 2 and root 3. So root 3 should always be opposite to pi over 3, which is equal to 60 degrees. So those are things that we want to keep in mind for this question and the next one. So cos 120 is in the second quadrant, so cos is negative in quadrant number 2. We also know that we're looking for the reference angle of 60 degrees. Cos 45 is in quadrant 1, so that's going to be positive. And then also, we know that sine 120 is going to be positive as well, so we can leave it as sine 60 degrees with a negative in front because of the negative that is already there in the equation. And then sine of 45 will stay as it is, as positive. So I've replaced them with their reference angles. Now, looking at 60 degrees, we know that cos of 60 is equal to adjacent over hypotenuse, so we're going to have to write negative 1/2. And then cos of 45 degrees is adjacent over hypotenuse, so that'll be 1 over root 2. Minus sine of 60 is equal to, if you look at the 60 degree angle, opposite over hypotenuse, so that'll be root 3 over 2, multiplied by sine 45, so that's opposite over hypotenuse, also 1 over root 2. So with these values, I know that I have negative 1 over 2 root 2, subtracting root 3 over 2 root 2. I have common denominators, so I can put them together by going negative 1 minus root 3 over 2 root 2. And lastly, I'm going to rationalize this because I don't want to have that radical in the denominator. So I'm going to multiply the top and bottom by root 2. So that's going to give me, when I distribute that root 2, will be negative root 2 minus root 6 over 2 times 2, which is 4. Okay, so I would leave it like this because you can't put unlike radicals together. So root 2 and root 6 cannot be combined. So that would be my final answer. Example 3, you're going to split 10, 11 pi over 12. We're going to split it as pi over 4 plus 2 pi over 3. So these will still add up to 11 pi over 2. And then what we can do is we can use the identity for 10a plus b, which is equal to 10a, which is pi over 4, plus 10b, which is 2 pi over 3, divided by 1 minus 10a multiplied by 10b. So when we're looking at a triangle here, so if we were to draw the special triangle here, we would have two triangles, one being the 45, 45, which we already drew, and 45 degrees is pi over 4. So we can use the same triangle over here because we know that tan pi over 4 is in the first quadrant, and that would be equal to opposite over adjacent, which is just 1. So the opposite side is 1 and the adjacent side is 1, so 1 divided by 1 is 1. Plus, if we're looking at the special triangle of pi over 3, well, pi over 3 is equal to 60 degrees. So pi over 3 is always opposite to root 3. Our hypotenuse is 2 and our adjacent side is 1. So if we're doing 10, we're doing opposite over adjacent, so that would just be root 3 over 1, which is root 3. Our bottom would look like 1 minus, and then 10 pi over 4, we already know that that's equal to 1 multiplied by, and then we also know, so before I continue, I do need to write that this root 3 should actually be negative. The reason being is 2 pi over 3 is in the second quadrant, so that would occur in quadrant number 2, and 10 is negative in quadrant number 2. So we need to write negative square root of 3 as well for the bottom, which is tan 2 pi over 3. Once you have that, you're just simplifying, so it's going to be 1 minus square root of 3 over 1 plus square root of 3. Now we're going to rationalize this by doing the conjugate. So we're going to multiply the top by 1 minus square root of 3 and the bottom by 1 minus square root of 3. So that gives me 1 minus 2 root 3 plus 3 if you do FOIL at the top, and FOIL at the bottom would be 1 minus 3. So that will give us 4 subtract 2 square root of 3 over negative 2. Now we can divide both of those terms by negative 2, which gives us negative 2 plus square root of 3 as our final answer. So this would be our final answer to represent tan. Example number 5, they're giving us that cos 2a. Well, if we look at the identities, we know that from looking at the previous pictures, cos 2a is cos squared a minus sine squared a. Well, we need cos, but all we have is sine a. So we know we're in quadrant number 1, so I'm going to draw a triangle there. Looking from a, we know that our opposite is 4 and our hypotenuse is 5. Well, if we do Pythagorean theorem, we can find that the adjacent side is actually 3, because 5 squared minus 4 squared equals 9. And if you square root that, that gives you 3. So now that we have all the sides, we can now do cos. Cos of A is always your adjacent side, which is 3 over your hypotenuse, 5, and then we're going to square that because it's cos squared A. Minus, we already know that sine A is 4 over 5, and then we would square that as well. So that'll be 9 over 25 minus 16 over 25, and that's equal to negative 7 over 25. And that's our answer for cos 2A. Okay, so that's it for our lesson 6.